Why are whales so big? I mean really, really big. The blue whale's heart is the size of a golf cart and you could fit your head into their major arteries. They grow up to 30 metres long. That's about 2.5 buses, almost as big as a Boeing 737. They're larger than any of the dinosaurs. Come to think of it, all mammals that live in the sea are huge. The smallest land mammal, a shrew, which is about the size of a bumblebee, is thousands of times smaller than the smallest marine mammal, the sea otter, which is about the size of a Labrador. Basically, mammals that live in the sea are all really big, even the small ones. Yet the largest mammals on land, the African elephant, is only 25 times smaller than the largest marine mammal, the blue whale. So there's less variation in body size of aquatic mammals compared to land mammals. And although marine mammals are from unrelated groups, whales, manatees and seals, each group independently evolved to be a similar average body mass, around 500 kilograms. So what's that about? You may have noticed that if you stay in the water for some time, you get really cold, even when it's warm. This is because you lose more heat from your body when in the water than when you're in air. An easy way for a mammal to counteract the cold is to get big. As your body gets bigger, your volume increases faster than your surface area. You generate more heat in the core of a bigger body, but you lose comparatively less of that heat from your skin. But you can't get infinitely bigger because those bigger bodies demand more fuel. And there's only so much food that an animal can find and catch. So for marine mammals, the need to stay warm sets a lower floor on how small they can get. But how much they can eat sets an upper ceiling on how big they can get. So mammals living in the water are big, yes, but not too big and not too small. The Goldilocks zone, where a mammal's size is balanced between being big enough so they don't lose too much heat in the water, yet not too big that it will cost them too much to find food to support that enormous body. But wait, that optimum size of 500 kilograms, that's a long way from the Labrador-sized sea otter, or for that matter, the enormous baleen whales like the blue whale. As always in biology, there are exceptions. Sea otters are really tiny for a marine mammal, but they're doing something completely different to keep warm. That exceptional fur, it's the densest of any animal, it traps air close to the skin, so the water doesn't even penetrate. They don't even bother having a thick blubber layer like other marine mammals. But they can't dive deeply because pressure would squeeze out that insulating air and let in the cold water. And at the big end of town, the enormous baleen whales, well, that's a different story. We think of baleen whales as being enormous, well, because they are, but they weren't always. In fact, it's a relatively recent phenomenon, recent in evolutionary terms. Whale-like creatures show up in the fossil record about 55 million years ago, but the early baleen whales were about the size of a dolphin today. It wasn't until around 4.5 million years ago that we see the giants of today. At that time, a combination of changes to glaciers, winds and currents drove nutrient upwellings. Here in yellow you can see phytoplankton blooms in the eastern equatorial Pacific. These surges of nutrients feed hordes of crustaceans like krill and amphipods and small fish like anchovies and sardines. Baleen whales that were able to filter feed quickly harness this abundant prey. For example, a blue whale today can eat up to 4 tons of krill a day. Those ancestral filter feeding whales got bigger and bigger. And their enormous fat stores, along with specialised physiology, allowed them to fast for months. This meant it didn't matter that those huge food bonanzas were sparsely distributed. They had ample fat stores to sustain themselves as they travelled the food deserts of the open ocean in search of the next food swarm. Baleen whales like the blue whale, the largest animal that's ever lived, were now superbly adapted to this boom-bust nutrient cycle.